Hello, my friends, and welcome back, everybody. Today I'm in super cool environment, all of these lightings. I just wanted to, replace my whole lighting system in my room. So now we're like in different colors. Linux developer in pink. Okay, so today we're going to continue our investigations and implementation of the connection to from Go to PHP via the pipes. I remember that yesterday we finished on the decision that we need to somehow pass to the PHP our new piped file descriptors. Or I don't know, somehow try to re-implement this how we implemented in a previous implementation. So we have basically we have Excalibur. So let's start from the paintings as usual. So we had previously implementation based on here is Go. And Go can connect to the PHP application through the several types of transport. So first of all, you can connect via the pipe. This is the standard pipes. I mean, like stdr, out, and in. So that's the first option. Second option is to connect through the Unix sockets. Invite painter. So the difference is, I think, slightly difference in the speed, slight difference, and also in the mechanism how you connect to these pipes. So first of all, you need to initiate this connection from the Golang part. So you should start a server, which actually will connect to the PHP counterpart with like Unix socket. So you have to signal to PHP that I want to connect via the socket, and PHP should like start accepting connections, like push a connection to you, and you should like connect to PHP application and like instantiate this connection, and everything is fine. This is slightly slower. I mean, I would write like this speed. So first pipes are most speedy ones, and the last one is TCP. So TCP is like, is slowest one, but is like, most stable one, because it internally it supports all of the stuff related to the CRC checking, package checking, everything like this. So, but it's like approximately 5% of slowness, and this one approximately 10%. Specifically for me, I never used, so I used just for the testing, but I never used these two transports. So because I don't need to. Pipes are the most fastest and most stable transport from these three. They're all stable, but mostly I'm using only pipes. So, and for the sockets, how we can connect through the sockets? So it's like trivial. So if we wanted to allocate a children of our master worker, if we have like here our, let's say, master worker. So we only need to instantiate this connection, like please fork yourself, and here is the children. Just it's C. It's children, and we need to connect to the children by passing connection to the master worker. So this is, the simplest approach which we can apply on this, on this technique. So the same for the for the this can be applied to Unix sockets as well as on the TCP sockets, TCP transport. So and we don't need anymore to, so all collaboration now is going through this transport, through this Unix socket. We didn't touch any way pipes, so we don't care about this connection via the pipes. We don't care about that the shared file descriptors between master worker and its children. So the problem here is mostly lays in the field of performance. We will just like drop in 5% of our performance, and the most important thing that we also we can't drop a connection to the master worker, because all file descriptors are copied from the previous implementation to the new one, like I'm sorry, for the fork. So all file descriptors will be inherited, and the problems here is that if we close our socket in the master worker, it will be also closed in the children. This is a problem. Oh, I'm sorry. No. So I think, yeah, we can safely close it. Yeah. So sorry, it's my bad. I just forgot about this. Yeah. So since they are inherited, but they are not the same as we read previously in Linux programming interface. So you can safely close the file descriptor in the master worker. It will not be closed in the children. But this is. I think this is kind of unsafe approach here, because you can have an error, and you can have definitely resource leaks here, since you needed to close all of these sockets on the master worker side. So imagine the case if you try, so if you send a command to close and master worker by some like not understandable reason just like dies. So what would be with the resources? What would be with the children? It immediately becomes a zombie, and I'm sorry, not zombie, but inherited by the PID1. So this would be, I don't know, very hard to handle this case, I think. And that because I wanted to try our approach with the pipes first, rather than trying to get our previous Unix socket. I don't know. But so the reason is I don't think that we would be able to write we will be able to write safely to the children's stdr and std in and read stdr and std out. So this is a major problem here in implementation through the pipes. Yeah. So the major problem here is that we should, so we can apply the following approach. We can just reopen but it doesn't matter actually. So we force it to pass pipes to the PHP worker, and this, I mean, a more complex problem from the terms of PHP. So when we create a pipe, so as we see here, we have this is like pipe2 system call. So we should pass two file descriptors, like which we would be reading part and writing part. So unidirectional data channels that can be used for the inter-process communication. is used to return two file descriptors referring to the ends of the pipe. Pipe file descriptor 0 refers to the read of the pipe, so we can like from the it can be like from the perspective of the worker, we can like read from the one part, and from the perspective of the like initial process, we can write to this part, and vice versa for the pipe file descriptor 1. Yeah, so data written to the right end of the pipe is buffered by the kernel until it is read from the read end of the pipe. Further details. Yeah, and so since we already have 1, 2, 3 file descriptors opened, like std in, std out, stdr, we have to somehow tell PHP that, okay, we pass you these 2 additional file descriptors in which you should like write the data. Moreover, we have only like pipe can locate only 2 like read end and the write end pipes, but we need 3. We need 1 which we can send data like std in of the from the perspective of the workers, so of the process. So we have a process, and we have a like in the process we should like be able pass the data via std in and read the data from the out. So this definitely will be like 3 pipes. Like this one would be referring to, I'm sorry, 2 pipes, I think. Like this one we can use read write end for the std in. This one we can std out use like the second pipe file descriptor, and this is like we should allocate another one pipe, but drop one part of this pipe, like have only, you know, read part on our end and close immediately. This is this involves a lot of logic on the PHP side, and I'm not sure that PHP is able to. So since all of this kind of stuff is hard coded inside the PHP worker, where is it, by the way? Yeah, all this stuff, as you may see here, is hard-coded inside PHP worker. So instead of writing to the std error and reading on our side, we should be able, if we wanted to use pipes, we should be able to definitely like replace this std error with different file descriptors, like let's say 4, 5, and 6, the next in the row, and close like our std in, std out, stdr, and then in this case we would be able to connect PHP and go through the pipes like PHP children of children of math worker. I mean, so we would be able. But since all of this kind of stuff is hard coded, it would be you know, pipe out. Yeah, it would be super complicated to update PHP to support this. But this would be, you know, the most performant way to achieve this functionality. Okay, since we're not able to implement this on the pipes part, let's do this. Let's do this on the socket part. So, by the way, this is how our sockets works. We have socket server. So when we start our socket factory, we start with the socket server, and socket server listens for the incoming connection. as you see here. So it accepts a connection and then connecting with the socket relay. So socket also have, so this is super cool part in Golang. So everything implements like read-writer interface. So except like, socket relay implements read-write closer interface, but this is actually doesn't matter. So because we can like pass bigger interface into the smaller. So the cool thing is that we can use the same interface across the whole like implementation, like just read-writer. And here we are doing the following. So we are waiting for the installation, for the connection from the PHP side. When PHP sends us a connection, we are starting like internal relay. So this is super cool optimization. I called this size classes. We have 1, 5, and 10 megabytes pools, up to 1, up to 5, and up to 10 megabytes pools. So if you have requests like to the workers, they are cached in like in the pool, in the pools with respective size. This is done because, for example, if we have 5 megabytes pool, we don't want to. I won't use only one slice here. I don't want to use like a slice, pre-allocated slice of 10 slices of 10 megabytes because this is very rare to have 10 megabytes request. So often it's like 1 to 5 megabytes. It's like 99%. I think it's like up to 1 megabyte. And so we have a fairly big number of this kind of pools of the byte slices, smaller number of 5, and the rest is like 10 and more. So if it's more, we can just allocate a like dedicated array for this pointer to this data and then destroy it. So because it's very rare. And how this helps our performance. So if we have like hot and pre-allocated objects with like up to 1 megabyte, we can just get this byte slice, which is in size of up to 1 megabyte, and just write the data up to 1 megabyte into it, and then pass the data further into the like implementation to the like to write it to a socket or pipe or etc. So to write like a specific amount of data from this. So we are not deleting the data until the garbage collector delete data from the pool. We are not deleting it by ourselves. So we only like writing continuously and writing the data. So and passing all of this kind of stuff up to written size. This is, I know, this is somehow 10% of the performance adds to the RoadRunner. This is, and yeah, let's go back. Yeah, and this is just like pre-allocate and allocate our relay. So as we see here, since we have read-write closer, we only like send is write, receive is receive frame, and close is just close. So this is kind of easy to understand. And after we have a relay, so we asking this this worker with the PID. So could you please get us your PID? And we are connecting relay to the PID. So we store this relay into sync pool, and when we are trying to connect our where is it? Yeah, and after we start, this is our spawn worker, so we initializing it, starting it, so this process starts, and then when a worker sends his PID to through this factory, so we can just find by PID this worker and connect relay to this worker. And then just use, general methods, since it like read-write closer, so we can use just read-write without thinking about this is like I don't know, this is pipes, or this is network sockets, or whatever which implements ReadWriter. Yeah. Okay. So I think we can return to the PHP part. I mean, to our idea of piping all of the things to the PHP worker via the pipes. Later, I know. So I need to just binge the previous approach with the new one, and if we see no difference with our approach with Unix sockets, we'll just leave this idea as unrealized. Okay, so now let me just see. And this is the reason why in previous implementation didn't use these pipes, but now I think I thought I could re-implement it, but no. Since no. Let RoadRunner up cache result ticket. Yeah. Okay. Oh. Yeah, like this. Can we close this? Okay. Okay, so we already have fork. Protocol go. Yeah, so we have. We have fork. And socket factory. Yeah, we need to update our socket factory instead of updating. Instead of updating our pipe factory. Socket factory, hello. Okay, now let's think. What we need different to our original worker, yeah, that should our new worker should do. What should do our fork worker? I mean master worker. We should our junior worker not to do. Our fork worker basically should provide an ability to allocate a new worker. Yeah. And it should have the method called fork worker, like fork itself. And this will be this method will be used by allocator. Okay. I think so what's the difference? So we previously realized that there's no difference between the regular worker and master worker in terms of waiting. We can just pass that this is master worker and wait should be done. I'm sorry, this is child worker and wait should be done differently. So child worker waits. The only difference, the child worker waits differently, and that's it. So this is only one difference. And master worker should be allocated like a regular worker, but it also should be used here as an allocator. Okay. How we can use it as allocator here? Yeah, we don't need a fork pool anymore, but I'll leave it here temporarily. Where's our allocator? Yeah, here you are. And so what is the basic workflow here? So okay, we are starting the pool, yeah? Pool. Inside a pool, so since we have only one kind of pool, we pass an argument. Like use fork worker mode. FWM. This is fork worker mode. Interesting. So it's like reacts on press. Okay, so used for her mode here, it's like bool. In this mode, we should have on our factory, we should use like allocator with fork method. And this is kind of important, that we should use our fork method. Okay, so but the question is, where is at this diagram currently, where is our master worker? In which pool it is? It should be in, so it should be in their own pool. It should be in a fork worker pool, I think. Okay, so and we should also support command with the name wait command to make PC and TL wait ID. This is also kind of important to not to prevent like a zombie allocations, zombie resurrection. So we should either pass to our pool method I'm sorry, not a method, not a pool with like forked pool, or we should allocate with this new pool, with the forked pool, or with just a regular pool, but which have a method with the name fork, we should have it inside factory. Okay, so let's look at the code. Yeah, so we have a factory here, yeah, and factory is just a thing which allocates workers. But the interesting part here that we already have worker allocated in case of master worker. We already have it, and our next workers should provide us this new pool. And instead of instead of passing here a factory, it's like factory. Instead of being factory, we should pass here or pool or factory with pool inside. Okay, let's look at this factory. This should be not new socket server anymore. We should have function new socket with so it's like Java hello, the methods with the name length like 180 symbols, hello Java. Let's just we'll definitely shrink this method length, but let's let it be as it current name, net listener, timeout is time duration, zap, or we can add in options here. Yeah, we can add an options here and add a field called what kind of field we should have here? Pool. No, we can't use pool here. Yeah, we definitely can. Type pool interface, and we should only have one method with the name fork. Yeah, and this would be our pool. Yeah, and next we are going to declare type options is equal to func like this. Yeah, so like this. Oh, without an Rust, I'm sorry. So and we should add an like this for opt in in Rust. So I recently programmed a whole day in Rust, so forgive me. Range opts to, I forget how to apply. Oh, I can do like this, yeah. Mm-hmm. Yeah, so here we're applying in options, and let's add our first option, func with pool, and return a factory, and oh, no, not the factory. I'm stupid, sorry. Then options for sure. And return func factory, and here we are applying our func. I'm sorry, not func factory pool is equal to pool is equal to p. Yeah, so so with this case we are not break any compatibility, so any like backwards compatibility, so because options are optional, so you can just use function as you used it before, or like pass an option. So what we are going to achieve with pool, with master worker, let's say, what we're going to achieve with this approach. So first of all, we don't need here a worker at all. We only need to worker process here. We don't need anything. Just can safely copy all of this stuff. Okay. But instead, we don't need to initialize a base worker here, because we already have it inside the pool. Instead, we should use our pool, f pool fork, like this. Let me think. So with this method, where is it? I left it inside, yeah. Like this, okay. What? Oh, context and error. Why I pass an operation here? I'm kind of dumb, because I shouldn't pass an operation here. So what is the operation actually here? So this is like, you know, I'm not using inside the RoadRunner, I'm not using a like, you know, standard approach with the errors, because I don't need to this big like stack trace to understand what's happening. So I think no one needs to have a super big stack trace, because actual information like recently located in the first like 2 lines. This is like the reason of the error, and next like a function where it like raised. And the problem with and I replaced it with like operations. So this is operation static pool exec, and when error raised, I see only the reason and like a super cool formatted stack trace, like with like a few functions. But also I see this in a, like assemblies compiled with the debug flag. So in the production, I only see like the particular line of code and the like description of the error. Because so there is literally zero cases where I needed super like big information. And so if I need this information, like super verbose information about the errors, I just ask to compile with the debug flag, or I can provide a debug binary. So this is exactly the same. You can run it inside production. This is debug binary, but rather than print that like short stack trace and like have no operations, it will print like a big formatted stack trace with the reasons. So yeah, you should run 2 times. So you can ask me, like you can argue that in the like standard approach you need only 1 run to achieve this. But so I can't confirm this theory, you know. So I never needed even debug binary to provide to someone. And by some reason I passed, I think this is IDE error. So IDE extracted this method and you know did this stupid thing. But I'm like haven't taken a lot of attention on this. So okay, const op is equal errors operation static pool fork, and let's pass an operation. Yeah, and here we're going to use our fork method, and let's go to the factory and let's add this interface. My God. And we need only context and worker process and error. I think that's it. We should also update our pipe factory. And just so for the pipe factory, this method is no-op. Func yeah, and here is worker. Yeah, we actually don't need to use return errors.e. Okay, so we didn't break anything related to our test, I think. Yeah. Why spawn worker have this? We don't have. Okay. And our socket factory would have this new method, fork. Which should accept only context. And return a worker process and error. That's it. So this is cool feature about Go, that you can declare an interface in place, and this interface will fit if you like pass some structure which have this method, so it will fit this interface. And that because we are using here our pool, so our pool interface. So and we can pass it here. It would be super fine. But let's check one condition here before we start to forking. If factory pool is equal to nil, this is also not super cool to check interfaces for nilness, like I did here. So because interface can be nil, but the value, interface might be not nil, but the value under this interface might be nil. For example, if we pass, if we like by some reason store a nil in interface, so interface itself would not be nil, but the structure would be nil. And we like, okay, so we checking for nil, super cool, getting some method, boom, panic. But this is fine for our like initial draft implementation. And we're returning and nil and errors e new pool provided. Consider running with option. With what's the name of the option? With master worker pool. Yeah. Okay, so checked. And here we have our fork. We don't need this. So we also don't not need to start anything because it's already started, you know. So we already have a worker which already started. So process which already started. So we don't need to actually initialize it. We don't need to start it. We only need to fork it. And we pass a context here. And worker and error. We are like trying to kill it. And sending a nil here. And returning. So I'm sorry, not nil, so we send in an error to our channel. So because it's like inside the routine. Okay, so then we searching this. Okay, done. So what are you expecting? Expected. Oh. And like should be like this. Oh. Why it's not reachable? Oh, yeah. So if error. Yeah. So I missed a bracket. Go simple. Should use channel. Nah, I don't like this go simple. No, I don't like this lint. And he has like disappeared like a, I don't know. like a smoke. Okay, so next we have to find the relay with, yeah, so all other steps should be the same. Mm-hmm. Okay, so we have a method fork on a pool. Then we are calling a method fork why you don't see other implementations. And then we're going to this fork worker and we're calling pool fork hello recursion. This is not correct. We should not provide a pool. How we can solve this stupid task? So first of all, who should be responsible on forking the processes? I think so this should be a worker, because it's like, you know, it's the worker's responsibility. And worker already have this functionality. Yeah, fork and internal fork. Is in control. But this is not an actual fork. Oh yeah, this is an actual fork. So when we send in control frame to our like underlying process will read it, apply the fork command, and send us a PID, new PID, you know. So, and this would be a master process, yeah. And this would be our fork worker, yeah. Okay. And we should call not a factory call, factory fork. Should we have yeah, we should have on the factory, yeah, we definitely should have a fork method on the factory rather than having it on some other structure. So I don't want to change the signature of this function, yeah, because it will involve a lot of modifications, a lot. This function is used across, you know, across a few plugins, and I don't want to change. So if it would be like internal dependencies somehow located somewhere in our, like, you know, on the SDK, so it would be fine to change it. Like, so yeah, we could change the signatures inside the SDK. So, and if other dependencies depends on some kind unchanged structure or unchanged method, it will be fine. But yeah, so if we accept the factory, so we should deal with the factory. We can add a method on the factory, so this is not a problem, because so factory declared inside the SDK, so we can easily change it, but not the new pool method. Okay, so this seems legit. So we have to fork. We are going to socket factory, and inside socket factory, I think we should have so why I wanted to use the fork method specifically on this pool, but not on the like some kind of fork pool, because I also don't want to introduce a new data structure which would be only responsible for forking. So since it's only like a one method, but we should implement all of the pools method. We have to mock them like they like doing nothing because they are just empty. This is not this worker is not capable of handling the requests. Only one type of request, fork. And thus I wanted to like somehow combine these two pools into a single one, but with updated interface with the method fork. Yeah. And the difference is that we will allocate this pool and store it somewhere, and it would be managed. It would have you know, all of these properties of the big pool, so we can wait for the process, restart it without any problems, handle requests. I mean fork request, only one. We can somehow apply generics here, I guess. But I don't want to deal with calling generics. Okay, so we have no other. This is kind of strange. It like found only one implementation. And this is, you know, this is recursion. So we are calling this fork worker methods from the factory, which calls our fork method from the pool. But instead, I think we should use not a pool. We should use a worker here, not with the master worker pool, but with master worker, and apply master worker here and use a method from the master worker. Let me think how it would be, how it implement. Okay, so the only way is to pass a worker. Okay, so and with master worker. Okay, and we would have a worker and the method fork. It should be like, we don't need a context. We only need, we actually don't need anything. So our method might be like this. Yeah. But then we can't use these methods. Since we have only PID, you know? We can find relay with context. I think we only need a PID here from this worker. We don't need anything. Let me check. Yeah. Good. Super cool. We only need a PID, so we can update actually this method. And yeah, and use only PID. So we don't need to pass a pointer to the worker. We only need to use a PID. And PID should be int 32. Yeah, and like this. Boom. And here we can use boom, and yeah, where is the second method? Spawn worker. Why? So why it's used only? Oh, we don't use. Yeah, we don't need the second one. Okay. No, it's not working. We still do need a worker, like a good big worker. Where we can obtain the worker without changing like the half of our SDK. So the only way to get a worker this is why. So yeah, now I understand why I created a child worker here. Why I did this. Why I wrote this code. Yeah, so we can get only, yeah, and this is why I did the like different type of worker. So init child worker. So this is this is kind of new method which I needed to have you know, just to, so since the worker is already allocated, so I only need one thing. I only need to initialize the structure with the speed. I don't need to do anything different with except let me check. how can I? Why it's like it's closed. Can I initialize it with just a PID? So process, I don't need the process. Pools, okay. Command, I don't need finita state machine. Yeah, I don't need this. Oh yeah, this is problematic thing. Problems everywhere. Basically, the problem is here. How to read from std_error, since we can't read from std_error. Since this is not in our child, we can read basically, so we can read std_error from all workers. Like we can read it from, you know, from the master worker, because all pipes are. So if you send anything to std_error from a worker, I can read it basically from the DAP, like duplicate of the file descriptor. But the problem is that the output would be mixed. Output would be definitely mixed, like all letters would be mixed, because since it's atomic across the writes. So you can, like, if you write into like 2 sentences, for example, into std_error, so from the same process. This is like atomic operation in case of char. So chars would be atomically written, but not the whole sentences. And this will lead to that the whole sentence will be, the sentences will be mixed with each other. I don't think that this is something which can be solved. I mean gracefully. And this is why I dropped this implementation previously. So the question is simple: how we would read std_error from our children? If we find a way how we can read this, why we can't read std_out and write to std_in? And the way how we do this is to have a pipes, yeah, like this, std_error pipe. Why it's called pipe? Because it's like a piped output from the one process to the another. And thing is, yeah, as you may see here, and the most interesting part here, that Go closes file descriptors and relocating in like to have this piped output. And you can do this if it's your children, like your process is your children. You can do basically anything with your children. And our problem is that this is not our children. This is children of our master process, which is our children. But yeah, this is. Yeah, nice case. Oh yeah, and this is suspicious method called dedup. Oh no, it's only duplicates. Yeah, and as we see here, this is pipes. This is actually how it works inside Rust implementation. So you just pass if you want to pipe. So if you want to pipe an stdr, for example, you just pass an piped, like standard process piped, and voila, you have piped output. So you can read stdr. If you didn't do this, you won't be able to read stdr or stdout or write to stdin, for example. Okay, it's running. Yeah, this we saw this yesterday, that we can std out, stdr, and std in. Okay, so unfortunately, I don't know how to do this gracefully, and I think it's not impossible. It's not possible, I'm sorry, to do this even with the socket connection. So we have to, for children of our parent, we have to somehow pass file descriptors, or we can, we can manage it inside PHP, use this piped output, and somehow pass a file descriptors to us, and they would be like sequential, like 1 to 3 are reserved, not reserved, but this is like common for stdin, stdout, stdr, and it will be 4, 5, 6, 7, 8, 9, 10, 11, and up to number of the workers. But still, I'm not sure how it would behave if we use master worker as our base process. I'm still not sure how it would behave if master worker dies and all file descriptors which we pipe in through this master worker will gone. So they won't exist anymore. They will be inherited by the PID1, but we are not capable of using PID1. So in case of master worker fails, we have to kill all children's and reallocate the whole mechanism. And in case of, for example, if your PHP project leaks memory, and you are using number of jobs option, so for example, if number of jobs 10, worker will be restarted after 10 requests. So it would be super inconvenient to have all of this reallocations of the processes. I don't know. This is not a complicated task, actually. This is just, somehow architectural task. How to achieve this result? I don't know. So I don't think this is. Because the children of our master process is completely unknown to us. So this is a separate process. You can try to do the same thing to any process which runs under your user. For example, on Linux, you can it can behave in any way any process in the system with the same user and group, for example. And you can try to apply this approach to like basically any of these processes. This is not, you know, a case to apply it to only master worker. Let me think. Okay. Oh, where is our Linux programming interface? Pipe 2. Entering child process. Yeah, so might be we might have a simpler approach. Let's read a little bit about opcache. So might be we would be able to somehow like pass some kind of pointer, or use general location for all allocated processes, if it's possible. Might be this is option, just an option which solve all of our problems. PHP opcache shared memory. How opcache works. Can we? So there's nothing. We can't use a black theme. Okay, the PHP extension implements various functionality to speed up PHP in transparent manner. Okay. Shared memory. The primary purpose of cache is to cache compilation artifacts in shared memory to avoid the need to recompile PHP script. On Unix system, a single fixed-site shared memory segment is allocated on startup. To handle requests, PHP will then either fork additional process or spawn additional threads. These processes threads will see the shared memory segment at the same address. Oh yeah, so this is kinda interesting. So PHP will then either fork additional processes or spawn additional threads. So that means that if we spawn a PHP like process, it will allocate their own shared memory segment. But if so, why the memory is consumption of our approach of forking PHP worker. So in this case, PHP will either fork additional process or spawn, but these processes will see the shared memory segment at the same address. So I think the address is like it's might be somewhere predefined. Where's shared memory? It's not on the prods. Oh, def, yeah. Okay, so we have Steam. Okay, let's try to do the following experiment. Let's try to start RoadRunner. Let's compile it. And let's try to start it. I want to understand, will we see any additional entries here? So it's like, no. Oh yeah, might be this one. I don't want to remove everything. Oh, I removed everything. Yeah, yeah. So, okay, nothing. Yeah, it works. Run works. But where are all of them? Oh, do I have its yeah, maybe I don't have it in I didn't enable it. Op cache. Oh, yeah, here you are. Event models, op cache. Yeah. Bam. Nothing. Now let's check. Still nothing. By the way, let's check the performance with or okay, let's read further better. Okay, the thing okay, on Windows does not support forking. What? This okay, I need to check Windows fork. Sigwin, so come on. So what? So do the how Windows I don't understand how Windows then fork in the processes. So if it just choke or what? Fork for Windows. Clone. I don't know. Why? So it's interesting to me. Yeah, I know that the fork is a POSIX thing, and Windows is not a POSIX compatible, but they, I think, should have something. I know, like not to support fork, but to have the fork, or like clone or some kind of alternative. How Windows fork processes. Windows on the fork. And this is why it's so hard to develop something under the Windows, because, you know, all of these things you have to search. Oh, might be create process. Oh, maybe it's create process. Oh my god, this is so hard to read this documentation, you know. This is, you know, compare these two parts. Main fork. So how it looks like. Description, creates a new process. Da-da-da. Like options, errors, return values, conforming to, notes, examples see also. Boom. This is super easy to read, like create process function in Windows. What is this? It's like in optional, in out optional. It's like ls lp string, lpc string, bool, dword. And this is, you know, so big. Oh no, so I don't want to even look at this. Okay. Where is our... I closed it. Oh yeah. Yeah, so this is definitely, we behave currently as like as Windows, and this is super bad. As Windows does not support forking, this is funny. It is common to instead spawn entirely separate PHP process, which do not share any shared address space. This is a big problem for OpCache, and this is for the big problem for the RoadRunner, since we allocate separate processes, CLI processes. This is also a big problem for the RoadRunner, because RoadRunner also behaves like a forking, yeah, and it allocates separate processes, yeah. Yeah, the rise pointers into shared memory would not be valid across processes. This is what we're trying to solve inside the RoadRunner. This is exactly the problem. Yeah, I heard about this option of cache ID. So, but I also heard that this is available only for the Windows. Can we apply this somehow? Windows only. Why? Why? Yeah, and this completely solves problem with allocating like workers under the Windows. So if you, this is hard to say, but under the Windows it will work better if you have cache ID, and I think the memory consumption of the RoadRunner would be less on the Windows. And you know, this is hard to, you know, think about this when because Windows is better in this case, because it have this option. Why not to share this option to Linux as well? Why not to force it? Yeah, I understand the reason why it's only on Windows, because it's like, yeah, because Windows doesn't support forking, and fork will inherit this pointer to this opcache. But why not to provide this API to everyone? Maintain the separate behavior is something of a pain. Yeah. Yeah, the use of thread-based rather than process-based SAPI would be required. So a thread-based SAPI is ZTS, and this is called also thread safe. It's not very popular, as far as I understand, across the PHP community, but I'm working on, and here you may see my work. So this is my work to have all of this kind of stuff written in Rust and like bindings to the to the Rust, to the PHP sources. And here I will use not thread safe model, and this model called as called here is process based SAPI. I don't want to support actually the all of this ZTS stuff, and on Windows this is fine because on Windows if you use thread-based model, you still share for the process. You still share the same pointer for the op cache, and this would be this is fine for Windows. Okay, so I think. Some of the structures stored in the shared memory cache need, or at least want to reference per-request data. For example, while a function definition is generally immutable, it may contain static variables which will be different for each request. Similarly, function use a runtime cache to cache request specific symbol resolutions. We can store request per. Okay, we use a map pointer in direction instead. Okay. Yeah, and this is cool. Cool feature. It's not a cool feature. It's not a. It's like. Do you understand what's the difference between pointer and reference? So inside in Golang we don't have references. We have only pointers. Even unsafe doesn't have it. So inside Golang we have only pointers. So we can't create a reference to another variable. So it would be stored in different address anyway. So you can't have two references to the same memory address. You might pass a pointer to this memory address, but not have two references to the same memory address. And this is quite good that to understand what's actual difference between a pointer and a reference. Okay, in the current map, yeah. Basically, inside RoadRunner, I'm doing the similar approach to store. Unfortunately, I don't have references, as I mentioned before, but rather I'm storing the pointers to the workers to have an easy access to them from any part of the application. So they are like they are like mutable accessed references. Pointers. Yeah, so I think this is not like interesting thing, since we already understand that it's not supported under the Linux. We can maintain our own copy of the PHP sources, to support this on Linux. Let me check. Do we have, might be the ticket? Okay. Let me check this. Need to answer. Okay. Continue cache to avoid caching. Disabled. How to use op cache. I don't think that. So you just don't need to have this. Most of the users use FPM. By the way, this is an interesting question. How this implements FPM? How this feature implemented by the FPM, by the way. I think it should be yeah. Oh yeah, PHP FPM uses thread-based model if it's not thread safe. In the process-based model, yeah, so how it works in process-based, like in just a general mode. Let me check. Yeah, we have this function, PHP execute script. Could you please open? No? Allocation on a heap, I think. Populate globals. This is like PG, SG like markers used to populate globals for the like PHP, like yeah, super globals. Then stream init file name. Then execute scripts. Okay. I think that so I also have this a similar approach here inside yeah. So how it looks on the Rust side. So first of all, you need to you know create a bindings to the Zend API, so to export like these functions, so you can easily access them from C++, but so it's much more cooler to do this with Rust. So with Rust you can't directly access so if you have a like a compiled binary SO file, it's not a problem to link to this SO file and to have all the functions which implemented in this binary and just like load this, link with your code, and like using the FFI call the functions with actually zero cost. So you can call a function from like C from Rust with zero cost. Of course, if you don't have some kind of tricky types conversion, if you need a C string and etc., but generally it's zero cost. And so you need to create a bindings, and basically, so to achieve all of this kind of stuff, you only need to follow these steps like SAPI startup, execute script, and etc. And I think that where is it? Yeah, I think that this is this execute script here. Somewhere inside it, we have a pointer to inside the Zend runtime and PHP runtime. In this model of execution, we have this pointer to the shared memory, and we can use the same shared memory. And this is why I think FPM workers consume as like a really less memory than the RoadRunner workers, because RoadRunner workers works faster, significantly faster, and I saw this in a like numerous projects. But the main down draw of the using RoadRunner that it consumes slightly more memory. For example, if you use compare one RoadRunner worker and one PHP FPM worker, RoadRunner base worker will cost you 26 megabytes of RAM, but FPM worker will cost you, for example, 10 megabytes of RAM. So it's like almost 3 times less memory consumption. And so since we are faster, because we are not stopping the workers, we are just so we allocate our framework, like, or if you use like Octane or Spiral framework, so we have all of this state inside the workers. We don't need to rerun these bootloaders, all this kind of stuff, PHP stuff, I mean, and we can like execute requests without any like initialization steps from the PHP side, very fast. And this would be like, you know, because you need to execute a request inside the FPM, you need to start a process, start a thread, or start the process if you use process-based execution model. So, and this is also adds a latency to the request. You should initialize your request, your like things that inside this FPM worker, and then execute and then shoot down it. So this is a lot of work, actually, and I think somewhere inside, I don't know, it would be if we would be able to find this somewhere here is located an op cache. So let me try to find op. This is ignore, run tests. Oh my god. Zend op cache, shared a log. Get put. Oh, this is memdump. Zend accelerate in shared memory. Oh, this is interesting. And this is in then persist. Shared memory, shared global. Okay, here you are. Pointer to globals allocated in shared memory and shared across processes. Here you are, good friend. So, Dmitry Stogov 10 years ago. So I do like to like digging into the PHP sources and all of these PHP projects just to see this like 10 years ago and 20 years ago, and PHP is really old and there are a lot of commits from the people like 22 years ago. This is kind of fun. Okay, we have this shared global, yeah? And I think shared alloc startup, yeah, globals. Okay, this is Zend result. Have huge code pages. Do you have a huge code pages? yeah, so when they found in SAPI, I think they attach this then post startup CB. I don't know what's CB. And then this points to Excel post startup and accelerate post startup, I think. And this would be not non-shared memory dependent initialization. And here we initializing our shared memory. So I think FPM should have somewhere this like it's not like I think it's not like FPM like only FPM related stuff, but I think that this is some kind of part of the SAPI initialization. So when you initialize SAPI with the SAPI init call, then all of this kind of stuff would be initialized. Like here, as you may see, Zend executes script, and where is it? FPM mine, where's... No, not here. FPM run. This is what is thread safe thing. This is kind of clear. Yeah, SAPI startup. I think everything starts here in the SAPI startup. SAPI globals constructor, memsets and hash, PHP setup, SAPI content type, SAPI register pointers, post entry, then hash add memory. Yeah, I think this is what we searching for. Or not. Or this is related only to the Zen hash, some kind of thing. Zen register post entry, release, add memory. What is standing for? Like 6 years ago. Let me check what we have in this SAPI global structure. We have a serial context, request info, SAPI headers, read write. So all of this related to the actual request fastCGI, hash table, then long, SAPI started, global request, hash table, then function call info cache. It's not in the super globals. We have nothing related to the shared memory in this file. But yeah, so I think my guess is correct here. So it's somewhere in the initialization of the SAPI. So since we have this PHP execute script, then result, nothing. Then execute. I don't know, by the way, why it called Zend. What is actually Zend? Zend PHP. Why it's called Zend? Oh, this is company who created PHP or what? Zend can help support. Or this is just, oh yeah, this is related to PHP. Zend PHP. What is PHP? Zend engine. Oh, this is who wrote. This is. Oh, Zend is a company who's like behind all of this. I don't know, sources. Why should put like your company name on like literally everything, like Zend execute? So yeah, I can understand this is execute without Zend, so it's Zend execute, so it's some kind of Zend execute. What? Why are you doing this? Okay, let's move forward. Okay, so I think it's since they use all of this kind of stuff, I think this is how it works actually. It's for me it's more interesting how it FPM workers. If help work. So this is not an actual workers in terms of like threads. They are processes. And if so, we have to allocate a new process on every, like if we support this dynamic function, for example, the dynamic scheduler, in contrast to the on-demand scheduler, ensure that a certain amount of free workers are always available, so that requests can be answered without delay. Is this some function? Or it's only configuration? Oh, FPM children. Okay. Or it's just forking them. Zlog. Zend log. It's funny. Why to put everywhere like this, like Zend? So I guess so you can just put it in the first file so everyone will understand that this is kind of Zend thing. But so I get it. So I get it that this is Zend. Okay, so why not to put Zend FPM clock get? Oh yeah, children make, yeah. This is how FPM manages workers. So we have PID, yeah, structure children. This is timeout, worker pool. Yeah, so this is kind of basic structure to manage these children. If style dynamic, PM start server, starting on demand, yeah. So if we can resources prepare, yeah, so it's fork, it's just fork. So this is what we are trying to achieve here. Hello Yoma. Yeah. Yeah, each file name. yeah, each file name should be prefixes with Zen. Yeah, definitely. So this is kind of funny why it's like used everywhere. I never saw it would be like if RoadRunner like put on every function, every file, like RoadRunner string, RoadRunner log, RoadRunner like everything. Like why to do this, I don't understand. Might be to distinguish between some kind of log function and zlog, so it's kind of understandable. So if you have like different log functions, like it's okay like to have some kind of separation here, but so it's everywhere. And I think FPM doesn't have these Zen prefixes. It's because FPM was written not by Zend. So yeah, okay, might be. This is only guess. So yeah, FPM just fork itself. And why it works inside FPM and forks and our forks not working? This is yeah, and also like 13 years ago, like just this function said it like 13 years ago. Why not? Let me add this to the GitHub and see, maybe we can have re-updated FPM. Let's see this. PHP version 5. Yeah, it was like a long time ago. Why it's not working in our case? So they fork this shared memory pointer, which is located inside SAPI startup. And because of this, they can execute scripts having basically the same shared memory pointer across all executions. So if I understand this correctly, in our case, how we can achieve these forks? We can't actually do forks. So no, we can do forks inside inside our code. But threads are more preferably here. How we can actually... So by the way, Go doesn't support forking. So in Go we have... So if we like, we can support them. We can just use a system called fork. But inside the command interface, like exec command, Go supports only fork exec, like fork and exec immediately. So not like just fork. And I think inside Rust we definitely can fork. ourselves to support, like, you know, a different processes. But this would be, you know, not so easy to achieve. And at this point, fpm child resources. So yeah, we have like 0, -1 and default. Default is going our parent. 0 is our child. So this is why we initializing child with this structure. This. And this looks super unsafe in C, you know. So this kind of, you know, pointer to this structure, which is changed across a lot of, like, here, a lot of places where it's changed, like prepared. So in terms of Rust, this function is owner of this VP. So you can't use it basically here. Ba-bam! You have a problem with Rust. I think, I don't know, I heard that PHP 5 was like the worst PHP release as far as I remember. I don't know. I didn't actually use PHP in any way. And PHP 6 doesn't exist. And they released already, like, they released version 7. Like, why not? It's like RoadRunner. So RoadRunner version 1, RoadRunner version 2, RoadRunner version 2023. Boom! Like, we skipped a few versions. So it's like, it's common in our community. Okay. So this is how they managed all of the things. Is this one little line which we actually can't do. How we basically can do this in Rust? How we can fork this? I mean, so we can use just fork system call. It's not a problem for us. But I'm thinking about what place where we should do this. This would be definitely not a trivial task to support this model of execution, because the previous model, when we use just like a separate PHP clip processes, it was super easy to manage. It's not an easy to manage, but comparing to this, you know, to this management which happens here, we should, like, definitely, you know, re-implement all of the thing. All of this kind of stuff we have to implement. Oh my god, something new dropped into this code base. Let's see it, guys. There might be a moment when the child log event is executed. Yeah, hello Rust, hello. So it shouldn't be possible in Rust, and this is why I'm not trying to write. C is cool language. So it's super cool, and it's like I, you know, advise everyone to write something in C to try, you know, just to understand how memory allocated, how pointers works, how references works, how you need to manage memory, how you can like malloc, calloc, what's the difference, how you can free the memory, just to understand all of the things. But do not touch C++, please. C++ is a complete mess. So yeah, and this case is kind of, you know, trivial to have in C when you have this like a pointer which changed across like 10 function. So this is very easy to lose the context and somehow log event after like is execute after freeing a child. Yeah. And what was the fix? Remove the static. Okay. Okay, introducing a function. If not, shall return. Yeah, and I do like, and also like to understand what this is like. Case casting to void pointer to pass to a function fpm event set. You know, this is, yeah, C is super cool programming language, but not C++. Remember this, not C++. Okay, guys, I think this is it for today. I just remember you that next week on the Monday we would have a planning session with RoadRunner. We'll try to do this in the Riverside FM in this studio with our guys, Dmitry and Anton. So Dmitry is our PM and Anton is our CTO. So we are going to, you know, why I'm not logged in? I logged like a few hours ago. Yeah, and we'll try to, you know, to create a good content here in Riverside FM. So basically on the planning session we are discussing, we will discuss a SAPI tool, which I'm currently working on. This one. So it's kinda, you know, I already managed to start a WordPress. I never touched a WordPress, but I found it from the perspective of the user, like who starts it, super cool. I don't know why everyone hate this tool. I mean, from the user's perspective. So when it's super easy to configure, it's super easy to connect to database, and it's super easy to start. And it's like, when you start it and configure everything, so it like proposes to you a lot of like themes, a lot of customizations, a lot of like, I know that you can't run super big site on it, I think, or shop. I think what is running on this WordPress, I don't know, might be sites. But this is from my point of view super cool thing, and I managed to run this with my own SAPI. It's single threaded at the moment, so as you may see here, so I commented everything just to rewrite like 50 times in a row all of this kind of stuff. Full PHP, yeah, this is my famous test, full PHP. So, and as you may see here, I'm using a lot of things from the here. They are unsafe in terms of Rust from the, like, this investigation I made with you guys. So like PHP embedding it, and I think somewhere here we I'm sorry, we can definitely fork our process, yeah, and execute our script. To achieve the same. So it's like, you know, it's only 5 lines of code, but we recently saw like, I don't know, few hundreds, and we're like, yeah, we can do the same with these few lines. But this is a bindings, so this which saves a lot of lines of code for us. This is just a bindings, yeah. So I'm going to stream, I think, next week, working on this. Like in general hours, like 11 a.m. from till, I don't know, till evening. I'll try to do this. I'm not sure that I will do this, but yeah, so because it's a lot of concentration needed. Yeah, and on Monday, I think 2 p.m. Central European time, we would have this planning session. We will discuss the SAPI, what we are working for, and also we are going to be on a conference, on the PHP conference on the 27th of May in Poznań, in Poland. So I don't know. I'm mostly going to this conference to have a beer. So they have unlimited beer, so, and unlimited snacks, unlimited, like, I don't know, unlimited eat. So I don't think I'm super interested in what's would be discussed on this conference since it's only PHP related. So but I'm not a PHP guy at all. So for me, it's like, oh yeah, cool to meet with people, to meet with community. If someone wanted to talk with us, have a beer with us, we also would have some merch, like caps, hoodie, caps, hoodie, t-shirts with the RoadRunner logo. Oh, Yoma, you also will be on this conference, am I right? Or it would be super cool. I'll bring you like some merch. Oh, it's said to me. But yeah, so since you are like here from the starting of the stream, you may send. I think when I receive this merch, I would be super cool if I would be able to send you some kind of our like RoadRunner thing, RoadRunner merch, caps. I know. I don't know what we would have. What like marketing guys bring to us, but I think it would be caps, hoodies, t-shirts, and backpacks. I think like this. So would be super cool. I think and also we are going to have a short translation where we are. So in our Discord channel, so I would post funny photos when I'm like, yeah, so now I'm on this bar, like sleeping. So yeah. But also would be super cool to see creator of FrankenPHP. So it's Douglas, I think, and I would attend, I think, his presentation, because he did a good thing, because there is no documentation about all of this stuff. There is nothing across the whole internet. We have only one book called PHP Internals book. But mostly this book, like it's, first of all, it's like PHP 7 and 8, so it's like kind of outdated. Like, I mean, in this part, in PHP 7. And also this is basic explanation of the plugins, mostly of the plugins, and internal types, all of this kind of stuff, like what is zval, how it managed the memory. So it's like, it's cool, but there's nothing about how to work with the SAPI. For example, we have PHP SRC, and yeah, look at this. We have a SAPI, we have a embed. So embed, this is a like embed SAPI. This is a basic entry point. Oh yeah, entry point into the Zend engine. So for everyone, not only for FPM. And as you may see here, this is all information. I'll move slowly. That's it. This is all they think we should know about SAPI. And this is also okay to run it inside. All of this kind of stuff is covered, like what is minit and erinit, and this is covered in memory in this PHP internals book. This is fine, but this is not covered. Like, what is this? What is this? What is this PHP embed start block? Why it's here? What is the, where is it? Oh, where is this super globals? Process globals. What is they? What if they are? How to initialize them? What you should pass to them? So part of this content covered in this book, and this is thank you very much. Yeah, so access macros, and we can't directly map macros, C macros into Rust. So inside Rust, you should have, like, if you have like PHP function macros, this is a macros. This is not an actual function. This is just a macros containing a lot of things. So we should like unwind this and use it like naked. And this is additional problems integrating with Rust. But at the end, we have this cool project, X.php.rs. I also wanted to like make some promotion of this project and to these guys. They basically did everything related to mappings, like to mappings to the that engine. And so since this is PHP internal books, and since this book covered a lot of creating plugins, this is super cool to have this project as inspiration, as how it looks like. I'm also looking at it to get some kind of documentation how it works actually. And this is super cool project, and you can use it if you wanted to create a plugin, PHP module, and access PHP functions from Rust, like super easily, like this. As you can see here, it's like from Rust, and PHP can access your function, which you implement in Rust, like this, for example, PHP function, hello world, and hello world David, and hello David, because it's like hello and name. It's super cool, super cool. I don't think PHP will die because of these super cool guys. Like Franklin PHP, like we trying to achieve, like with RoadRunner, with all the things, and so I think PHP will live, but I don't touch PHP at all. I'm not working with this. So if everyone asks me like, do you know PHP? I like, no, I don't. Only Go and Rust. Sorry. Okay, guys. So I think this is this is finish of our stream, and as usual, have a super cool weekend, and see you on a Monday with on our planning session, and have a good weekend. Bye bye.